This is lesson 4.4, graphing high degree functions. The degree of a function is the highest power of x that is visible in a function. So if this degree of the function is even, then the function will start and end in the same direction. If the degree of a function is odd, then the function starts and ends in opposite directions. And if there's a reflection applied to the function, those end behaviors will flip. So here we see that the degree of this example is 4. It's raised to the 4th power here. And that's an even number. And there's no reflection here. There's no value of a that's negative in front of that coefficient. So a positive even function will have shared end behaviors going up in the same direction. So the degree here is 6. Is it even or odd? It's even. Is there a reflection? Yes. There's this negative sign in front of the function. So when there's a reflection on an even function, both of these end behaviors go down towards negative infinity. The degree here is 5. Is this odd or even? It's odd. There's not a reflection. So when there's not a reflection, they will start and end in opposite directions. So it'll start from the bottom, towards the bottom, and come up to the top. Now that we can graph the ends of functions, let's talk about the inside of the graph. We can use factors and roots to find what a graph looks like on the inside, so between these endpoints, these end behaviors. So a factor is a general, looks like x minus a, and a root looks like x equals a. So for example, if we have x minus 4, the root is x positive 4 when these equal to 0. So a root is where the graph crosses or touches the x-axis. So here we're going to find the roots of this function and plot them on this number line. Remember, we want the y value to be equal to 0. So we'll set f of x to 0. And so what value for each of these makes that statement true? So x equals negative 4. X equals negative 2. X equals 0. X equals positive 1, and x equals positive 5. So on the number line, we'll point it here at negative 4, negative 2, 0, 1, and 5. So now that we're familiar with what a root is, the multiplicity of a root is the number of times that same root appears. So the number of times So here, the degree is 2 because we know that once this is FOILed, we'll have x squared as our greatest degree. That's an even number. And the roots when we set x minus 2 equal to 0, x is equal to positive 2. Because these two are the same, the root of 2 has a multiplicity of 2. Because it appears twice. So the end behavior here, as x moves to the negative direction, y moves to the positive direction. And as x moves to the right, y also moves to the positive direction. So we can just graph this as a normal quadratic. For the second one, this is the degree of 2. This x will appear 3 times, so once completely FOILed and in standard form, x will be raised to the power of 3 at its maximum. Then 3 is an odd number, and roots of 2, as you see here, x will equal 2 with a multiplicity of 3 because it appears 3 times. Now remember, when we have a function with an odd degree, it'll start opposite of where it ends. So as it starts from the bottom, as x moves down, as it moves to the right, x will move up. So we notice about these two shapes is that at the root here, where x equals 2, the graph did not go through this point. Whereas in this odd function, where the root equals 2, it goes through the shape. It goes through the point. Basically, it crosses from negative y to positive y. So to demonstrate, for this function, it'll hit this point and then go back up, versus here, it'll come through the bottom, cross through the point, and go up. So as we saw, there are several types of multiplicity, each with their own shape. So the even multiplicity, I'm going to call that a bounce. And those bounces look like this. They hit the root and go back up. They'll hit the root here and go back up. The odd multiplicity has a bit of an S shape. However, when the multiplicity is equal to 1, it'll go through it like a linear function in a straight line. So for example, if the root is here, the S shape will go through it like this, whereas if the multiplicity is 1, it'll go straight through it like a linear function. So for our last example, we'll put it all together. We know that this x multiplied by this x multiplied by this x, which when expanded is x plus 4, will give us x to the power of 4 as our highest degree, which is an even function. And the roots here, x equals to 2, x equals to 1, and x equals negative 4, and x equals negative 4 again. So these two have multiplicity because they show up twice. So the roots are 2, 1, and negative 4. The multiplicities are at negative 4, multiplicity twice. They show up twice. So this end behavior, I just will go up to infinity because it's an even function. So we'll plot our roots at 2, 1, and negative 4. So we know that the general end behavior will look like this. So we'll start it here, And because the root of negative 4 has a multiplicity of 2, it's going to bounce here, and we know it has to come back down through the root of 1, then it'll go back up through the root of 2. These have even multiplicity, these have odd multiplicities of 1, so they'll straight line through it. Whereas this one has a multiplicity of 2, so it'll bounce.